So Dr. Hirschfeld, my son Andrew and I thank you for a great introduction. And I'm honored and humbled that so many of you are here today and to have an award that bears the name of Connie and Steve Lieber, who are two of the most remarkable forces that I've ever met to change the way that mental health research is done. The title of my talk today is Rethinking Schizophrenia. And the reason we're all here today is that those of us interested in schizophrenia or other mental illnesses know that these illnesses are not being adequately treated. And therefore, from the research point of view, I felt, and my research group felt, that it was important to begin to rethink the whole concept and how we approach it. And so that's the name of the talk. Our work has been funded by the Brain and Behavior Research Foundation with 2 Distinguished Investigator Awards to me, a number of independent and beginning investigator awards to many of the people in our laboratory, and this work and each innovative stage of it would not have been possible without the Brain and Behavior Research Foundation. Although the National Institute of Mental Health funds most mental health research, generally, it doesn't fund things that are as new and innovative as Brain and Behavior Research Foundation does. So it is really the catalyst to move mental health research forward. Inspired by the BBRF, a group of supporters, many of whom are here today, led by Dr. Nancy Gary, founded the Institute for Children's Mental Disorders, which has provided us specific support for the research I'm going to show you today, as well as the Anschutz Family Foundation and the National Institute of Mental Health. I have too many collaborators, too dear to talk to you about all of them, but you will hear today from Dr. Camille Hoffman, who is the Bear Award winner, and I'll tell you a bit about her role as we get into the talk. I think most of you have probably seen The Beautiful Mind. This is the year, unfortunately, that John Nash died. And the tagline for the movie is, he saw the world in a way no one could have imagined. And the movie does a great job of depicting both his genius as a mathematician, shown here decoding seemingly random streams of numbers for the Rand Corporation, and also his paranoia, delusions, and eventual descent into complete deterioration. We really can't imagine either Professor Nash's genius or his madness. But they do have something in common that I would like to point out to you. And that's, both of them were characterized by an unusual hypersensitivity to what was going on around him. Most of us screen out most of the information around us, particularly important if you're walking down the street in New York City, in order to concentrate on what we wish to concentrate on. John Nash, in his genius, was able to look at things that other people ignored because they intruded into his awareness, and that's what made him a wonderful code detector. But it's also what made him a very paranoid individual, because as the movie depicts well, the traffic moving outside became to him the stuff of spies and conspiracies against him. And so every time a light flashed in the night or there was a horn honking, which happens about every 3 seconds in New York, he was convinced that someone was plotting against him. We decided that this was a lead that we ought to follow. And so we devised in our laboratory a way of reproducing what people like John Nash were experiencing. And so we use a technique where we record the brain waves from the top of the head just by pasting a little white electrode on. Whoops. I knew I would blew this. There we go. And we play 2 clicks. Click, click. Now you all heard 2 clicks, but your brain processes the first click a lot differently from the way it processes the second. It already recognizes, by the time the second click has arrived, that this is information you've seen and heard before. And so your brain spends a lot less time processing it. And so what we see when we record the brain waves is a bigger wave to the first click and a smaller wave to the second. And so when things are repeated, people tend to lose attention to them. And almost everyone has figured that out but political advertisers, and you'll be experiencing that yourself very shortly. People with schizophrenia often respond to both clicks. And so their brains are hypersensitive to sensory stimulation, and that causes them a great deal of problems, which eventually will appear as hallucinations and delusions for all this information that they can't filter out or make sense of. Fortunately, in animal models, we can duplicate all of this. We can't duplicate schizophrenia, but we can duplicate the way the brain processes information. And we were able to deduce some of the circuitry that's behind this particular ability to inhibit the response to the second sound. And it's a rather complex interplay between interneurons and pyramidal cells. These inhibit these cells, and so when these cells try to fire too many times, these cells come in and inhibit them. So we then get less response to the second stimulus. The key thing we found out about this circuit is that it has a switch that switches it on and off. And that switch involves a neurochemical called acetylcholine and a receptor that is called the alpha-7 nicotinic receptor. And that turned out to be made by a gene called CHRNA7. So by looking at this circuit and trying to decide how patients were responding so much to sounds, we discovered both the quality of the circuit and also the switch that turns it on and off. And we suspected that that switch was abnormal in schizophrenia. There were lots of ways we showed that, but probably the most simple was just to sequence the DNA for that switch. And in the DNA, this is the genetic code of the CHRNA7 receptor, part of it. And right before the beginning of the synthesis of the receptor itself is a little region called the promoter or control region. And every one of these little red arrows is a place where an individual with schizophrenia or a group of individuals with schizophrenia have changed their genetic code. And so this little change, this one letter in the genetic code, is enough to cause less of this receptor to be made, and as a result, the patient is less able to work that switch. There are lots of other ways of showing it. This is from the Lieber Institute at Hopkins, and across the frontal cortex, they have looked at a number of genes that have all been implicated in schizophrenia, and this one is CHRNA7. And what the yellow line shows you is that across the frontal cortex, CHRNA7 is one of the most depleted of all the genes, and so it is seemingly a common key in many patients with schizophrenia. And Dr. Arnsten will be up in a little while to discuss with you exactly what it means for the frontal cortex to have less of its alpha-7 nicotinic receptor than it should have. Well, the other people who have discovered this for themselves are patients with schizophrenia. A nicotinic receptor means that it can be activated by nicotine. And people with schizophrenia smoke more heavily than almost any other group in the population. They smoke their cigarettes down to the butt often to retrieve as much nicotine as possible. And that's consistent with the alpha-7 nicotinic receptor that requires a lot of nicotine to activate it. And I've given you a quote here from Ellen Sachs. Many of you have probably read her book, The Center Cannot Hold. One of the first things she noted about her own mental illness was an attraction to cigarettes. So patients have learned that this is one of the ways to activate their alpha-7 nicotinic receptor. The problem is nicotine is not a very good way, because nicotine through smoking is very toxic. You can't really take it effectively to activate alpha-7 nicotinic receptors through patches or lozenges. You really have to smoke it, and in addition, it doesn't last very long. So we set out to try to find a better nicotine. And eventually we found it, and it was in this little worm. This worm lives off Puget Sound. It's called an emertine worm, and we don't kill worms anymore, but we are able to synthesize this compound 3,2,4-dimethoxybenzylidine anabasine. It's kind of a name that rolls off your lips. We went to every drug company in the National Institute of Mental Health to try to get help to make this into a drug that could be given to human beings. And everyone turned us down, too new, too novel, except Narsad. And Connie Lieber stepped forward with a Narsad Distinguished Investigator Award so that we could go ahead and make the drug and give it a try in patients. I won't show you all that clinical data, but we did talk to the patients who got the drug, and one of them told us that she had a short story that she'd been trying to write, and she was able to finish it once she had the drug and could concentrate better. And another one who was less of an author just told us, or his mother told us, that for the first time he was able to take in the scenery around him. He was amused by watching rabbits play in the yard. Rabbits had always been playing in the yard, but he had been too distracted by his own hallucinations and delusions to appreciate them. So patients have been feeling better on this drug. The drug companies that couldn't come around and help us before also couldn't be left behind. And so there are, almost every major drug company has tried to make a drug like this, and two of them look like they may succeed, and their drugs are in final stages of clinical trials. So I hope that this will be available to any family who needs it for an affected individual very shortly. But our job is not to make drugs and try to sell them. Our job is to rethink schizophrenia. And so we began to think if we were doing the best we possibly could. And we began to realize that genes are not there because the divine plan, at least as far as I know it, was for pharmaceutical companies to come along someday and make drugs for each target. They're there because they're the plan for the brain. And they're the plan that allows the brain to be formed before birth, from a single cell that decides it won't be a skin cell to almost an entire brain by the time the baby's born. It's a rather dramatic transformation from through many, many different stages through a very short period of time until by 9 months there's nearly a completely formed brain with everything in place, ready to go, from an individual who has never seen or heard anything while it's been in utero. You might think of it as buying we're right next to the Apple store here, I noticed. You might think about buying a succession of Apple computers, each one bigger and better than the one that came before it. And all of this is done within 9 months. I think Steve Jobs would be envious. But just like the development of new computers, each time the brain makes a transition from one step to the next, it changes its operating system, just like your computer does. And so there are a succession not only of different brains, there are a succession of different operating systems. And so we began to study all those operating systems, and I won't go through all of this molecular biology with you, but CHRNA7 itself, you might think of as OS2, the second operating system of the brain, appears very early in fetal life. And just like in your computer, the old operating systems have to install the new operating systems. And so when the last operating system is installed, OS5, that the baby will be born with, CHRNA7 gets active again, and it makes GABA, the inhibitory neurotransmitter that was responsible for the second sound having less intensity than the first sound, that final transition and some other related transitions require CHRNA7 during development, or they don't happen quite as well. That's of significance because these steps also don't happen very well in schizophrenia. So people with schizophrenia never quite fully install that last operating system. And we think that CHRNA7 is one of the culprits. So we wanted to see what inhibition looks like in a newborn baby. So that's one of these guys. Now, we're used to difficult to handle people in our laboratory. We deal with psychotic people, we deal with suicidal people, but we've never dealt with individuals like this. They scream, they fuss, they tear off the electrodes. They're very difficult people. But they usually come in with their mothers, and their mothers know how to handle them. And fortunately, they sleep like babies. And while they're asleep, they're difficult to arouse, which means we can play our clicks, and they don't tear off the electrodes, and their brains look like they're awake. And so we're able to record evoked potentials, really nice ones, from babies like this. Now, just for fun, our baby recorders like to record with the potentials up, so you see the response to the first sound and not to the second. So already at birth, that GABA inhibitory system is working just fine in this young man. But a baby from a psychotic mother frequently responds to the first sound and to the second, and you'll notice that the waves are a little broader and not so well formed because their excitatory system is not working well either. So already at 1 month of age when we did this recording, this baby is already showing the physiological stigmata of his mother's psychosis, and we suspect that this baby will continue to carry this signature for the rest of its life and be at risk for mental illness. And so we decided it made sense to look a little further into what the underlying biological issues were. And so we looked again at our circuit. This is the one I showed you before. And we looked to see what it looked like in fetal life. And we saw something quite different. The neurons, of course, are more immature. And there are many more of these alpha-7 nicotinic receptors, about 10 times the number. And so we had our first realization in Rethinking Schizophrenia that if we were intervening here in adult life, we'd really missed the ball game. It was here in fetal life. And we noticed one other thing about the difference between these two diagrams, and that is this cholinergic innervation doesn't actually grow into the area of the brain we study, the hippocampus, until just before birth. So this alpha-7 nicotinic receptor that we thought was so important isn't being activated by this cholinergic switch. And so we began to think about what is activating it. And we realized that it was choline itself, not acetylcholine, but choline, which is in the amniotic fluid of the mother. And it's there in sufficiently high concentrations to begin to activate these alpha-7 nicotinic receptors so that they can do their role in OS2 and OS5 and all the steps in between. And so normally, the system works quite well. The mother has sufficient choline levels, she activates sufficient numbers of alpha-7 nicotinic receptors, and the baby develops its brain just the way it ought to. But sometimes mothers can't get in quite enough choline for a variety of reasons. And sometimes there are not enough alpha-7 nicotinic receptors. And so when these two occur together, or sometimes when they occur separately, we end up with a baby that is not able to develop its cerebral inhibition. And so we wondered if we simply gave a very large dose of choline to the mother repeatedly during pregnancy, like every day, could we overcome this genetic deficiency and end up with a baby that was born with normal physiology? Now that may seem rather improbable to you, but in fact, obstetricians do it all the time, because it was discovered that compared to no treatment, a woman who gets supplemental folic acid has a much less risk of developing a baby with cleft palate, spina bifida, and other problems. And these neurodevelopmental problems are just as multigenic and complicated as schizophrenia. But if the mother gets overdosed intentionally on folate, most of these structures will continue to develop normally. The palate will close, the spinal cord will close, and the baby is born normal despite carrying the genetic risk for cleft palate or spina bifida. And we wondered if the same thing could be done for schizophrenia. Notice that it requires the folic acid supplement. Just good diet and vitamins alone doesn't carry the whole effect. And even in the absence of good diet, folic acid and vitamins still trumps good diet and vitamins. So the supplement really seems to be necessary, and all obstetricians therefore routinely tell patients to go get their prenatal vitamins that include this extra dose of folate. So we wondered if we could give an extra dose of choline. It's actually given as phosphatidylcholine, and we ask mothers to take 4 capsules in the morning and 3 in the evening. And Camille Hoffman, who will come up here and talk in just a few minutes, was the obstetrician and maternal fetal medicine specialist who stepped forward to help us with this project as our partner between obstetrics and psychiatry to make sure we ended up with healthier mothers and better babies. Now, every trial that a scientist like myself does has to have a placebo control. We obviously didn't want mothers purposely deprived of choline. And so every month, a couple of weeks, an obstetrical nurse visited each mother in their home. She was not aware of what treatment they were getting, the placebo or the active ingredient. And she was instructed to make sure that no mother was choline deficient by going through their kitchen cabinets, helping them cook and prepare food, and making sure that everyone had an adequate diet. And she was convinced by the end of the study that she had washed out every effect. But she hadn't. So you know how to read these as well as I do now. This is a baby who was on choline at 1 month, responding to the first sound and not to the second. And this is a baby who was treated with placebo and responds to the first sound and the second with those broad, immature potentials. Well, squiggles are not what make mental health, and that study was done 4 years ago, and we now have some young children who've grown up. So babies, regardless of what their brain potentials look like, look pretty normal. But by the time a child is approaching 4 years old, their behavior patterns are pretty well set, and their parents can reliably tell us what they are. So children treated with choline have gains in attention and social withdrawal at 4 years old. They are much less likely to have social withdrawal and much less likely to have attention problems compared to children who are on placebo. And that's of significance because children who will have schizophrenia, looking backwards from adults who have schizophrenia, their parents report similar-sized problems in attention and social withdrawal. So with the choline, we have wiped out, in these 4-year-olds, about the same magnitude of problems that would be associated with later schizophrenia or ADHD or similar problems. I want to emphasize that this is not a treatment for patients who already have illness. This is a treatment of mothers who might be related to someone who has schizophrenia, and it affects another generation. Now, one of the unfortunate things about doing human research on the life cycle is it's the same as your life cycle. I'll be 135 years old by the time we finish this study, so I'm glad that young people are the focus of BBRF. And a young investigator will have to call me in the nursing home and let me know if this works out just the way I planned. We've also only dealt with the very first stage of brain development. This is what the brain looks like at birth, and it's 6 years old. And there's some important transitions as children get older. And Dr. McGorry, who will be on in just a few minutes, will talk to you about interventions during this adolescent transition. But this is only step 1 in brain development. But it is rethinking schizophrenia from the beginning, and it is putting children, at least some children, on a better path to mental health. I don't know if these children will continue to have mental health all their life. I know they're happier 4-year-olds. And I don't know how many children ultimately will be positively affected. But every child saved, for me, is a blessing. Thank you very much.
Don't leave. Questions for Dr. Freedman? Actually, I have a first question. Do you think you're going to be in a nursing home at age 135?
I think that's the best outcome I could possibly have.
And if you come up, we're not going to come up to this. You're going to hand the speaker? All right. Either way, it's fine. Well, while people are doing that, I've got another question for you. The anabasine, did I say it right?
Yeah.
Could that be a treatment for smoking in general?
So we have looked at anabasine as a treatment for smoking in general. One of the problems is that it works only for a very short period of time, and that's a problem with all nicotinic receptors. That's why cigarettes taste worse as the day goes on. So it doesn't look like it's going to be a great smoking treatment. And people with schizophrenia smoke in a rather unique pattern. They smoke much more deeply and heavily. So the average smoker who can take a couple of puffs and put the cigarette down never activates alpha-7 nicotinic receptors. Everything in the brain is complicated. Turns out there are 10 different nicotinic receptors.
Other questions? Yeah, here's a question right here.
Hi. So can a pregnant mom, in
Hold
general,
it up so we can hear you. Thank you.
so adding choline to a prenatal supplement for every person, maybe one day, is that safe or just
Yes.
for?
So it's, the question is, in case you didn't hear it, would every woman take choline if this turns out to be successful, or just women who are at risk in some way? The risk for mental illness, as most of you probably know, is widely distributed across the population. Although a baby who has a psychotic mother has a 10% risk of becoming schizophrenic herself, most 90% of children who develop schizophrenia do not have psychotic parents. So this would have to be something delivered population-wide. And that means two things. One, it has to be extremely safe. So we were very fortunate that a nutrient could be used that is extremely safe. You noticed I didn't talk about side effects because, in fact, this is a normal nutrient that women eat all the time. And second, it has to be generally promote brain growth for all women. And so it has both those characteristics. So it would be then very similar to folic acid, which also has those characteristics.
I hope this is on. Yes. About 60 years ago, Dr. Hoffer from British Columbia wrote about the use of nicotinic acid and niacin supplements, as well as choline, in his work. And many of his patients are very happy because of that. But this has been going on for over 60 years. So I think even with adults, there could be some benefits for niacinamide and niacin. Thank you.
Right.
Excuse me, since it's not available yet, should pregnant women eat 3 eggs a day?
No, I don't think I could hear that.
Yeah, should pregnant women eat 3 eggs a day instead of the choline? Is that?
Right. So,
If it's not available. I think actually it is available, but
yeah.
anyway.
So first of all, if they want to do this with eggs, they certainly can. They would need to eat 6 eggs a day. So they'd need to eat 3 eggs for the normal portion and then additional 3 supplementary eggs. They could also eat 1 great big serving of calf's liver. And I once gave this talk in Italy, and it turned out everyone in the room was a female psychiatrist who was expecting grandchildren. And so they were just like you, all ears. And I said, you know, American women won't eat calf's liver. And they said, Americans don't know how to make calf's liver, so how could this happen? So yes, you can do this by diet. These were very stressed women and relatively economically impoverished, so I don't think they could have even afforded that kind of diet, but it could be done entirely with diet. However, phosphatidylcholine is available in the grocery store. It's not a drug, it's a nutrient. And so if you go to the aisle that has all kinds of vitamins, you can find it there. And it doesn't have to be particularly pure because, again, it's something that's in the diet. So you just have to make sure you get enough of it. I think there's a question down front here.
Thank you so much for your presentation. Are there any studies being done that someone could participate in regarding the nemertine worm?
Are there studies with the nemertine worm? Yes, we continue to do studies with it.
And how can we find out about that?
How are we funding that?
How can we find out about the studies?
So the best way to find out about studies is on clinicaltrials.gov. Currently, our current study is only open to veterans because the VA makes us restrict our study to veterans, and they're currently funding the study. The studies of the drugs that are being developed by drug companies, unfortunately, are all being done in Eastern Europe. I suppose you could go to Eastern Europe, but it turns out that's the cheapest place to do drug development, and that's where Abbott Pharmaceuticals and Forum are doing their studies at the moment. So we're hoping that they get through them, and then this drug, one of their drugs, will be released to the general market.
One more?
Thank you very much. Could you just help us connect the dots between these prenatal and neonatal chemical imbalances, if you will, and the fact that schizophrenia doesn't really appear until the late teens and the early 20s? Is it just a constant deterioration since the prenatal environment?
Right. So I think the word is, the assumption in your question is a common one, that schizophrenia is silent from the time of birth until it suddenly appears on the scene. And if I can get off the stage, Dr. McGorry will be on quickly, and I think he will deny that as I would. If you actually look at people who develop schizophrenia, they're in trouble very early. It's more subtle, and that's one of the problems in doing long-term developmental research, is that from a very large group of people who at 4 years old have increased amount of social withdrawal, attentional problems, to a group of 7 or 8-year-olds who have difficulty making friends, to a group of 12 or 13-year-olds who are having the beginning of school failure. This is a pattern that, in retrospect, most people with schizophrenia follow. And if they're studied intensively, you find out they have deficits all along the way, just like our 1-month-old child who already has abnormal brain waves. But the illness itself doesn't seem to appear to the point where ordinary clinical attention will suddenly say, you have an illness. And so parents can be very frustrated because it looks like their children ought to be able to grow out of it, and pediatricians will frequently say, this child should grow out of it, and most of the children will, quote, grow out of it, but a number of them will not. And so preventive efforts, we always have the criticism, even from our scientific peers, that most of the people we're intervening with will never become ill. But again, it's the same way with folic acid. We give it to everyone, knowing that just a few people in the population would develop cleft palate, but everyone has to be treated. So it's not like the illness is silent for 20 years and then erupts. It's developing all the time, and we just have to decide to get it early, which means we'll get it before everyone says, this person has schizophrenia. Obviously, babies don't have schizophrenia.
Thank you, Robert.